what are the challenges in the telecom sector with respect to AI and why is it needed there so badly. And then we can also dive into some fun and novel applications that are kind of relying on the telecom network, and they also need AI there. Let's take the next one. So with every new generation, with every new G, which typically one iteration of this Gs it's one in 10 years. So it's quite a massive amount of work that's being put into there, and a massive amount of research that's been put into there. And as you know, with every new generation, it's all about, you know, having the network more reliable, more fast, bigger bandwidth and so on. So it's more open for other supporting different types of services. And 2G was really about connecting people with mobile phone. 3G was already, we had some kind of internet connection there. So, but it was still only for the providers themselves, the operators themselves, to kind of release some kind of services. When 4G came, and with the app stores and with all other devices, that was already a network where you can run other applications on top. With 5G, it's a major shift. In my eyes, 5G is a completely different beast compared to the previous Gs, because not only it goes faster and bigger bandwidth, this is what we're kind of used to, but connectivity kind of enabled such a wide range of needs, such a wide range of services and devices there. And it's serving kind of as an innovation platform. So we have enabled so many new applications. And one of the super cool novel concepts of 5G is that we have virtualization on the network. So exactly like what we've done, the shift from dedicated hardware to virtual machines, where you can request your virtual machine for a period of time when you need it, and then you can tear it down when you don't need it, and that happens super easily. Exactly the same thing one can do with the network when you kind of, without having a deep technical knowledge of how the networks work, you can request a dedicated network for you with a specific quality of service that you need for this specific service. And that's called network slice. That in essence, it looks and feels as if it was your dedicated network where you specify different qualities that the network may need to have. And there are different use cases. So here in this picture, you can see, for example, the network is supporting augmented reality, it's supporting robotics, smart manufacturing, connected transportation. For example, when driving when a truck is going autonomously somewhere, when it doesn't know how to do, maybe it requests a remote control driving, and then that immediately leads to the very high demand on the uplink when you send a very good video feed, and that's a very safety critical use case, as you can imagine. Then of course you can have use cases that on the opposite, they are not safety critical, but say in agriculture, where you have massive amounts of sensors and actuators deployed in the field, and every little sensor that's sending kind of information up somewhere in the cloud, that's not mission critical as such. But in that case, that is most important, the battery lifetime. You don't want to go to the field and change massive amount of batteries there, but rather you want to have some device that doesn't drain the battery because of the network connection. Let's jump to the next slide. I just wanted to show how Ericsson works with artificial intelligence. And at Ericsson Research, where I belong, we have started about maybe 15 years back with data analytics. We started with machine learning. We started, trying to show in a small scale, trying to show the potential. And now it has really, it's really took off in the whole company, and it's being used in all the business areas in a whole product and service portfolio. But it always kind of starts with the customer needs. So there is some kind of need owner or opportunity owner saying like, okay, this is my case, and then the business owners fetch this case and come to us at Ericsson Research and to our global AI accelerator, which is also another global organization who are taking care of productification and scale up of all the AI features. I should also say what's interesting, that's a slightly different question than just technology, but it's super interesting still maybe to say in this community. How does a big company that's 140 years old and has more than 100,000 employees that had a lot of focus on radio telecom networks, all of a sudden does this transformation and try to add artificial intelligence in all its parts? It's not an easy process, because if you're kind of a system architect or a software architect, you know that you need to design it having artificial intelligence in mind. So you cannot just say, let me put something on top. We have developed, say, for example, a network, and let me optimize something just by scanning some signals. You can do that, but it's not super efficient. The most efficient thing, of course, when you have full observability of the data that's coming out of all the internals of the telecom system, which is actually the next big thing for 6G networks. When the 6G networks are being developed, then it's really becoming an AI-centric thing, where we are kind of planning the system architecture in the right way. I typically have an analogy with a human body. If you only scan the signals and the symptoms, if you have a pain somewhere, then you may fix the symptoms, but you want to get at the root cause and to fix the heart, probably. Let's jump to the next one. That's a very high level overview. But some time ago, we did start with scripting quite a bit, and with RPA, with the closed loop runbook automation, with human guided automation, with machine learning. And now we are actually doing quite a bit of mix of machine learning and machine reasoning, and I'll come to that. That was a kind of super interesting when the decision came that we need to mix learning and reasoning, and in fact, all the knowledge bases are being populated with learned knowledge, and there is a very interesting interplay nowadays. And the main vision of this thing, let's jump to the next slide, is that we are saying that we want to have zero-touch automation in our network. This is being called zero-touch networks. And we have a program across the whole company that's called zero-touch real-time distributed zero-touch automation, where the end point, kind of the end game, is that the whole network is fully automated. And there is also a telecom standard, SAIS zero service management, that explicitly says to have all operational processes and tasks, for example, delivery, deployment, configuration, assurance, and optimization, executed automatically, ideally with 100% automation. We are not there yet. There has been quite a lot of work being done. We used to be a very human labor intensive company before. We used to have about 40,000 people working with our managed services, serving all the, like, a lot of networks in the world, managing the networks in the world, where telecom operators outsource their operations to Ericsson. That means that there you have a front office, and you have the second office, and then you have a back office resolving any type of issues that may arise in the live network. And then, of course, you can imagine that algorithms can do quite a bit there. And of course, front office was the first out there to be automated and to shift the human labor to more advanced tasks, actually. So the vision is that full automation. The vision is that we are not depending on the human, but the vision is that we may have the human in the loop on our terms, right? So it's like picture number 3. When there is some kind of question, that then it's allowed. Let's jump to the next one quickly. I typically have this analogy: when you have a data lake, and then you add all this kind of, we do have all this assistance everywhere. We do not have a name for our we don't have an assistant, actually, an AI assistant for the company. But some years ago, I was approached by so many different companies saying, like, let me automate, or like, let me help you with your operations. We can just give us your data, we can help you. The problem is that, of course, if you're not organized in your data lake, if you actually don't put all your observability and data everywhere in your data lake. If the AI engineering didn't take place, there is no it's not so much of a help. Then you're just fixing the symptoms. So for me, the data lake is, was the prerequisite that we fixed in the beginning, having common structures where all the data feeds end up, and also having the common knowledge bases. I will show you just a little fun example that I made, but that was really based on a true story. If we flip one slide, coming very early when I started at Ericsson many years ago, I was, we had an abbreviation finder in the company. We still have it. And then when you ask what's MSDP, and then you click once, and then it would tell me, MSDP can stand for multicast source discovery protocol, multi-service delivery platform, or managed services delivery platform. And these are at least three valid abbreviations that are being used in the same company. And when you're new and you get this abbreviation, then of course, as a human, you have a context. And then my AI helper would actually say, well, judging from your recent stakeholder dialogues, I believe it's the latter. It's the third one that is you're after. And then I would ask, let's click once, what are your sources? Because you want to have some kind of explainability from your algorithms. And then it would say, let's click, it says—
I checked Ericsson product catalog, CPI store, Wikipedia, and your calendar.
It does talk, right? You heard that. So it's searching many different sources, including my own sources and so on. And then in the end, you get some kind of proposal, what's out there. And let's click another one. So obviously we are in this type of business to business huge infrastructure provider. It's not about talking to your devices and talking to your things. You just want to have some kind of decision support and proposal, but you still want a system to run and optimize something for you, which is actually happening. So the system is out there and optimizing things. But then at some point you may want to, have a human in the loop and ask, you check in. It's almost like, I want my kids to do their homework. I want these operations just to roll nicely. I want them to come with high grades. But then from time to time, I would ask them, what have you done? So let's click once. In the same way, we're asking, okay, so what have you done for operator A last month, for example? And then there can be a lot of things.
Parameter configuration in the 5G network nodes. I also sent offers to subscribers with high risk of churn.
Perfect. And then, of course, we want explainability. So let's click again.
Because we need to stay competitive towards our enterprise customers while keeping our subscribers happy.
And I'm totally aware that explainable AI is a huge research area on itself. So of course, we need to kind of understand the decisions, and there's a lot of research being done here. My point here really with this little fun demo is that, let's click one, the values and data. And it's only as good as your organization data is, and as good as you have organized and learned it and stored it. That's how smart your AI tooling would be in the end. And my role, what I typically say at my role is, let's click once. In Ericsson, we are really, polishing the unpolished diamond. So there is a lot of domain knowledge, and there is a lot of amazing things. So I'm that machinery that's actually on the next slide. We are that machinery that's polishing the diamond, because there are so many interesting insights out there. We just need to be there to link them in a good way and to figure out the best optimal decision support out of them. So let's click another one. All in all, combined in one slide, this is what I'm up to. This is how we kind of organized our research topics. Really out of what is it that is, what is telecoms, what's relevant for telecoms. And for telecoms, we are working in the real-time world and resource-constrained world. 5G has 1 millisecond latency. So sometimes you need to have very quick closed loops in these networks. We're working with algorithms with online and closed loop learning. In some cases, you need to be able to, you don't have so much compute. The network is distributed, so you have different types of capacity on your nodes, and you can execute your algorithms in the nodes as well. But that's always a trade-off: what to send, where to send the data or the algorithms, and where to execute. It's a distributed and decentralized network, so it's a huge distributed system as such, all the way from the data center to network edge, and there are so many different nodes with different quality of service in the middle there. We are taking care of model lifecycle management. It's part of our AI infrastructure research. And then, of course, federated learning is just the perfect kind of research topic for a telecom company to look into, for obvious reasons. Because when you optimize even network of one telecom operator, it's a distributed system. So the nodes are everywhere in geographical distribution. And then it's very beneficial for us to work with federated learning, and we've seen many very good results. And even when you have several telecom operators, they can help each other through that, unless they're competitors. And then for that, they need to dictate the privacy regulations and who and how and with whom they collaborate, of course. Closed loop methods with reinforcement learning, and super interesting, how do you do exploration in real systems? How do you experiment with reinforcement learning in live systems? And how do you do safe exploration in live systems? As you can imagine, what's fun about telecom network, even though you don't see it, but it's a critical resource, because when you run kind of remote control operation of heavy machinery, or even if you run remote control surgery, you can imagine that even human lives can be at risk. So when the network is not functioning as it should. So experimenting in live networks like Spotify would do, it's not okay. So we are always looking at, safety first and trustworthiness first. Confidence and guarantees, we're working with conformal prediction Bayesian learning, and actually trade-offs between speed and quality and the guarantees. Quite a bit of standardization is being developed there as well. Then I'll come to that, but we've started with building some knowledge bases and reasoning some years ago. We do have, we always had knowledge bases in the company. Of course, you do have all the knowledge bases with your kind of possible solutions to trouble tickets, and all the knowledge bases for the product documentation, and all the knowledge bases with how you build your products and so on. The tricky part was the consolidation of those, and actually having them as one kind of source when you can link them. Because the cool thing also is when your thing that, having the full life cycle in your hands, kind of, you build something, you put something together, you manufacture in a plant, and then it gets rolled out and put somewhere in the world. And that piece of network equipment that has both hardware and software is being kind of misbehaving, and then your end consumer starts complaining, or you detect a service degradation. And then you kind of need to backtrack it and see what is the root cause of that. Is it a hardware problem? Is it a software problem? Or did we didn't think of some weather conditions in that country? We didn't think of, there are so many different root causes to that. In the knowledge bases, we are combining declarative and procedural knowledge, meaning that declarative explained with ontologies, when we reason what systems are and what things are, and procedural, where you can describe how the processes look like, and also AI planning is also being included there. And in infrastructure and tools, there's also quite a bit of research, because even the best AI algorithms won't be so efficient if you don't have efficient infrastructures to run them on. And let's jump to the next one. So there are selected AI areas at Ericsson that are very, I mean, these are my applied contexts essentially. Working with artificial intelligence in a telecom company is, I mean, it's really good because you have a lot of context. Without a context, it doesn't help, right? You always need to put your algorithm in a context. And there are many. So obviously with our 5G networks, you have radio access network, you have transport and core, all the parts of the network where you need to kind of optimize the end-to-end chain. When you when you have some kind of quality of service guarantees, you need to optimize the full network. There's a network optimization and automation, and also real-time aspects to take care of. Digital support solutions, these are the monitoring and management and monetization of the networks. As you saw, we are working quite a bit on zero-touch automation. So the vision is that the self-optimizing, self-operating networks, but not only self-operating, they should also be intelligent, right? And also customer journey optimization. Then we have our network services, what I was talking about, the services that are actually running operations in telecom for telecom operators, where we have more than 1 billion subscribers in our networks actually. Optimization in cloud with resource allocation and general infrastructure resource optimization. There's a lot on energy optimization as well. Of course, where you have your network when it can predict the demand and scale up and scale down its operations, so that exactly like what I was saying with virtual machines, that you don't just have it up and running when no one is using it, but then you can actually tear it down or parts of the network down. Security, there's AI for security and security for AI, of course, with fraud detection, attack prevention, and privacy. And then there is also an IoT dimension to all of it, where all the connected devices are coming to the play. And there are different selected verticals that the company is working with regarding manufacturing, transportation, smart cities, where all of them need predictive maintenance and logistics optimization. Let's jump to the next slide. And in this one, we are talking about the interplay of machine reasoning and machine learning. So on the blue box is kind of more numeric methods, where you produce the machine learning models, you produce predictions, features, and actions. And the blue box is populated by training examples and is contributed to the extracted knowledge in the orange box. In the orange box, we have the machine reasoning, which is more symbolic, where you have the knowledge bases, where we're storing our knowledge. And we can also inject, populate it with expert knowledge. And out of that, you get the inferred knowledge. And these are kind of rolling all the time and improving each other, kind of. But it's the orange part that's in many times giving us decision support. And let me put it into context on the next slide. So in data-driven operations with machine learning, when you don't have machine reasoning at all in your system, that's how we started actually. When you don't have it, then you have some kind of customer and business strategy input on top. It's being fed into the telecom system, but the input is being kind of inserted manually. So you have the business strategy, and then typically like sales representatives, they try to understand the requirements of the customer. We try to map them in the technology characteristics of the network, and then we try to configure the network out of that. It's being done so that on the left-hand side, when you have a lot of acronyms: operator support system, business support system, radio access network, core, and transport. You read out the data through the data pipeline, you plug in your machine learning use cases, you do prediction, and then typically you hand it over to human supervision, or human guided supervision, where the best action is being proposed and actuated on the nodes, and then the loop is closed and it's becoming better. So we wanted to kind of not to be dependent on the human, and then we worked quite a bit on improving this human supervision box through machine reasoning. And let's jump to the next slide, where we did work on intent-based networks. The paradigm is the intent-based networks. So when the business intent is coming in from the top, for example, you want to improve the network quality. It's being translated to service level goals. So for example, perceived throughput improvement by a customer, that in its term is being split and translated to network level goals, and being kind of sent to relevant nodes. So on the bottom you have actually the actual different nodes, parts of the network. So there are goals of radio base station site, and there are goals of core network, and there are goals of IoT. And then it's being split. The whole translation is done through this machine reasoning and knowledge management module that you see on the right-hand side, where kind of the intent is being fed into the knowledge base and the reasoner, and this split is being done automatically. And then the same component is actually doing the proposing the candidate actions and determining the best action, how to actuate the nodes. So we took this one that we called intent-based networks component, and we fed it in the previous slide. So we'll jump to the next one. We jumped this animation. Okay, I already talked about this one. So now you can see the orange part. The orange part kind of color coding the machine reasoning components here. So in essence, we do not depend on the human input here anymore. The business intent from the customer is being directly kind of put into the machine reasoning intent-based management box and being translated to how to operate the nodes. And then in the same way, you have your data coming into the kind of machine learning. The machine learning is proposing a number of predictions, and then a machine reasoning model is selecting the most appropriate action to be taken, and that's being actuated directly into the actuation box and fed back as before. I don't think this kind of fully automated flow scares this community. I typically absolutely love automation and love the vision of zero touch. But I can, of course, you know that, but I can, of course, say a word of kind of disclaimer that, of course, there's an opportunity for a human operator to jump in and override any step of this chain. Of course, but just to be capable for the network to optimize this loop by itself, it's pretty cool, I think. Let's jump to next slide. That's an example of zero-touch automation. That's the same thing that I was talking about, but just an example I can show you. So when the network operator puts a high-level intent, and he says, I want to optimize voice over LTE, that's essentially the network standard for G service in Manhattan. So you're defining the area. So the algorithm is looking for that area. It's monitoring the business intent status and all the relevant key performance indicators. It goes into the reasoning block, into the knowledge management block, translates the intent into different lower level intents, key performance indicators, finds a machine learning agent that can optimize the target KPIs, jumps into the trained machine learning model. The model is giving you prediction, and then back to the reasoner, evaluate possible business intents and different prediction, pick the best one and actuate. Then the loop is closed, and then you see if you've succeeded to improve your KPIs or not. Let's jump to the next one. Now to something slightly different. We've been discussing for some years how cool it is. I mean, how the advances of artificial intelligence are playing out, and then you know, artificial general intelligence versus narrow artificial intelligence, and then how narrow are our tasks, right? So AlphaGo Zero was an impressive success, of course. It is still a narrow artificial intelligence because you have well-defined rules of the game. What are our rules of the game, essentially? Of course, it's not as narrow. I mean, there are plenty of parameters and they're changing all the time. And it's quite often you still optimize in some kind of open-ended world. So I have an analogy here. If you jump to the next one, what are the rules of the, let's see, let's jump to the next slide, please. Yeah, thank you. If you just draw an analogy with the sports, if you say like the industry is like sports, right? You have your rules, they have the rules, and then as soon as there is some kind of sportsman that discovers some way of, you know, staying within the rules and regulations of the game, making the whole game unfair, then this rule is immediately changed. So you have I mean, it's either unfair or simply not entertaining anymore. When you have, for example, let's see, the 3-second rule in basketball, or you have rule changes in hockey, or you have like changes preventing players for standing in front of the net to distract the goalie. When the game is becoming unfair or not good in some way, not entertaining, then the rules are being changed. So exactly in the same analogy, I think that's super applicable to industries as well. When regulations come, and let's go to the next slide, and that's a proposal. On ethical guidelines for trustworthy AI that's been proposed by European Union and established by Ericsson. But even more, now there is actually a proposal for regulation. So that's a stricter one on trustworthy AI. And that's a set of rules in essence, so that we have to adhere to, and we have to translate to requirements and impose those requirements on our algorithms. And of course, these rules are changing. They will be changing over time. So back to where I was starting, on importance of a good system design. You need to design your systems in order for allowing these quick rule changes. If you want to insert a new policy, then you should be able to do it very efficiently, and then all your technology complies to that. Let me quickly jump to the next one then. I promised to talk not only about telecom, but some other stuff that's running on top of telecom. And we do work with robotics as well, because partially we do have our own manufacturing facilities where all our equipment is being built, like antennas. Partially, since they're manufacturing industries, they are often customers to Ericsson, and we are looking at about autonomous robots and collaborative robots. So cobots, collaborative robots, meaning that it's not like that they are working with each other, not like in the picture below when there's a cage and they're assembling something together, but it's rather on the first picture, it's a human working with a robot. So if you open that cage down there and let the human go into that cage, hopefully it doesn't kill you, right? So the robots need to sense that it's safe, or there is a safety for the human there. And there are a couple of, let's see a couple of examples if you jump to the next one. Tesla assembly line. As you can see, there are plenty of robots working together. There is another one, if you jump to the next one. There are some humans there as well. This is, I think, Tesla being assembled. in the line. It's absolutely autonomous. The question, thank you so much. Yeah, perfect. The question is what happens in this factory when you want to have a human entering the factory. If something happens, 1 minute of downtime costs automotive manufacturers $22,000 per minute, or $1.3 million per hour. So it's extremely costly for them to stop the process. So we never want to stop the process. That means that somehow maybe you still want to have a human on the floor, on the factory floor, but you don't want to interrupt the process. Let's jump to the next one. It's always a trade-off. We know there is always a trade-off. Of course, it's safety versus productivity. If the factory is absolutely passive or very slow, then it's typically very safe. But you also want to have high productivity. So the question is how to maximize productivity without sacrificing safety. And I can say that you know the answer. This community knows the answer. Of course, artificial intelligence is the answer. So we can jump to the next one. So there's quite interesting work being done on kind of using AI to ensure safety in factories. Can we take the next slide, please? Where we define a virtual safety zones for each object that is out there, and it's actually not for humans. It's only for the robots. It's only for the things that are surrounding us. So the things become completely aware of their own, for example, speed, how dangerous their operations are, how the speed of motion of robotic arms, and if there are humans around or other robots. And let's jump to the next slide. There is, interestingly enough, Volkswagen did implement a similar thing. They introduced dynamic safety zones, but what these are for safe cooperation between people and robots. And that's cool. I mean, they're showing it on the factory floor, actually. You know what, the only thing that I think is suboptimal in this picture, and let's jump to the next one, I will tell you immediately, because the zones are actually for the human, because it's warning the human with red and green and stuff. But in fact, I think the zones should be virtual and for the agent. So that's each cobot is an intelligent agent, and reaction times matter, and the network is a critical resource here as well. And there's a local process.
I'm experiencing some audio issues. Is it only me or?
And that.
Sorry, Elena. There are audio issues.
I think the network connection is unstable. We just have to wait until.
Yeah, switching off the video is a good chance.
Okay.
Maybe you go ahead without video.
I removed my video. Do you still hear me?
Yes, very good now.
Okay, thanks. Let's fingers crossed. Okay, let's jump to the last one, to last topic here. Yeah, so very quickly, some food for thought for Internet of Thoughts. And that's kind of a new paradigm. Let me quickly introduce this to you. Next slide, please. So Ericsson founder actually said communication is a basic human need. He said that more than 100 years ago when Ericsson was founded. I wonder, so when he was saying communication, that of course, it was in a broad sense, right? This is still a very human-centric slogan. It's still a one-ended communication. But how do we telecommunicate with each other? It's evolved a lot. I mean, from letters, telegrams, calls, now we're texting, and there's a lot of help for us to text, and there are predictions on our keyboards. Let's jump to the next slide. I think that this is absolutely some kind of transition period, right? That we're walking around in the streets and texting. I think writing, it's kind of very old-fashioned thing. I think dictating is amazing. Let's jump to the next one. We know that the machine learning accuracy. Do you still hear me?
Yes.
Okay, perfect. There is a huge improvement on how accurate the algorithms can predict things, and this is a graph for Google. So we have really achieved very good accuracy when you dictate. But let's jump to the next slide. You simply don't talk to Siri in public, right? That's the problem. That's my problem. I would absolutely dictate, happy to dictate a lot, but you just don't do it in public. So there should be better ways. And let's jump to the next one. Yeah, this one says essentially, imagine a world where all the knowledge, fun, and utility of today's smartphones were instantly accessible and completely hands-free. Dedicated now, the ability to type directly from our brains may be accepted as a given. Not long ago, it sounded like science fiction. Now it feels with plausible reach. And from this slide, I just give you a couple of examples of what's out there already now. So if you just run through them very quickly because I'm out of time. There is a brain-computer interface released by Facebook. Let's take the next one. There is a brain-controlled drone races out there. Let's jump next one. There's a mind-controlled robotic arm without brain implants. Let's jump to the next one. This one is absolutely mind-blowing. It's an exoskeleton that you control with your brain as well, and actually it reinforces and recovers the brain muscle signals. And let's jump to the next one. That's the last slide, actually. So it's a food for thought, but I think it's super interesting. Internet of Thoughts is coming. So by 2030, we'll control things with our brains. So think Avatar. They will be non-intrusive brain-computer interfaces available on mass market. They will be very quick control loops. Think of combining this with augmented reality and virtual reality, and you can think that we can actually implement telepathy through that, because if you can send a bit of information to each other with your thought, then you can encode anything if you're a computer scientist, right? Thanks a lot. That's the end of my presentation.
Thank you very much, Elena. I have a very interesting and nice presentation. It's very impressive, all the work that you do. So we have received one question in the chat here. Are there theories that guide on how to balance safety and productivity?
No, that's a good one. I think that's in general the multi-objective optimization. That's the one, right? So you encode your safety constraints and you encode your productivity key performance indicators. So you get your multi-objective optimization. Then there's a trade-off. And then in practice, I think we are just after searching for some kind of Pareto optimal choice, right? But in practice, you need to kind of state your safety constraints. I mean, those are non-negotiable, and those vary for different industries. I mean, you can have, for example, like zero tolerance for, some kind of accidents at work, but you can still tolerate some kind of degradation in the network in certain cases. So safety constraints non-negotiable, and then out of them you optimize the performance. Generic answer, but I guess that's how it is.
Thank you. I don't see any other questions. So if you have more questions, please write them in the chat or in the question and answering. So I can ask one question, and I mean, you are operating many different networks in different countries and so on and so forth. I'm curious, how generic are your solutions, and kind of how much do you need to, retrain or recode different things? I mean, the knowledge bases and so on. I mean, how much of that is kind of specific for each installation?
Yeah, that's a good one. They are different per country. So the regulations are different per country. Even that set of EU guidelines, these are for European Union. Then for China, they don't even have GDPR. And in US, there are different sets of regulations. So models are generic. I don't think we recode them, but we rather impose these constraints as a boundary condition. So you kind of, you build in a generic way, but then every deployment requires the boundary conditions that differ per country.
That sounds at least reassuring. So that it's a lot of very much reuse. So maybe I can follow up on that. I mean, considering you mentioned the EU regulation, so I mean, this new AI Act that's currently out on comments. What's your general impression? And I mean, do you think it will have a large impact on your systems, or are your kind of the way you have built things are kind of already prepared for this?
It's being assessed. I mean, what measures to take. But even from the beginning, when even when it was a guideline, we kind of took it very seriously. I think that's like, I mean, historically, security was one of this. You know, all the products are being very well tested when it comes to security. Now you have AI trustworthiness as well, so which is a different beast. I mean, which is a very tricky thing, of course, to comply to. Very seriously, there is research being done, and then with this latest one, you need to analyze which services are, which parts are treated as high risk. I mean, to kind of differentiate the whole portfolio to see which is high risk and where. And then, of course, where it's high risk, then we need to take the measures. And the network will be high risk in many situations when it's put as a component in high risk scenarios, of course. But luckily, I mean, we are relying a lot on university collaborations because we want to stay like to know about the latest and greatest with the, you know, how to guarantee trustworthiness. Super important. So, I mean, I feel like I'm not giving a good answer here, but I see the importance. The importance is recognized. We need to do this. It's a good thing. That's what I want to convey, I think, with my answer. Then, of course, we can, you know, do more. Yeah.
Thank you very much. So I think Marcus has a question. Yes. First, one small thank you very much also for the presentation and very nice slides and also good storyline and so on. I was wondering before I come to my question, just is it okay if you share these slides, or are they confidential?
I'll share.
So yeah. we have already the Dropbox link. We can just link to it from the program page. Perfect.
Sure.
I have a question. In the last slides, you motivated and I think quite similarly that it's very likely that soon we will be in a non-verbal way able to interact with whatever AI we want to. However, when really digging into the deep bits, like when I want to try out in some fairs these prototypes, or when I look into the deeper research of these recognition of whatever inner speech or so, I always get quite disappointed. I still have a feeling, okay, these promo videos look nice, but if you really want to try it out in reality, we are still not there yet. On the other hand, we also interested in doing research in such direction and have already initial research and research ideas, but then searching for funding is also not very easy. There's a Google Brain, no, not Google Brain, sorry, the Human Brain Project in the EU, of course, there's a lot of funding, but it's again, where are the tangible applied results there? So what's Ericsson's standpoint? Are you just following, or are you also doing research in this direction? Or
by these brain-computer interfaces, we have it as our we call it like technology journeys. I mean, when developing a network, the next generation, now we're working on 6G networks. Of course, we are looking on what kind of applications are out there. So what kind of needs for the network, and then if we we believe that they will be like Internet of Senses, and like you will be able to transfer like I don't know, smell, tactile feedback, and so on. So for the enhanced experience, and this is one of them, brain-computer interfaces. So that would be, if that's possible, then it will be driving completely different requirements on the network as well. So that's from that angle, monitoring. But then, yeah, so it's monitoring as of now, because for us, I guess, brain-computer interface, that's yet another sensor and yet another device. But it's like you know, chicken and egg problem. The technology, if it needs to use the network, then the network needs to comply to the, you know, it has to be very quick. For example, if I want to send a word in that, then probably there's has to be quite a bit of compute and network capacity corresponding to that. So that's more from the need, from the angle of like, okay, that's an application, what needs to be done in the network for that.
Thank you, Marcus. Any more questions?
No, I think it's also okay to close the session.
Okay, good. So then I thank you very much, Elena, for this very nice presentation, and wish you all a nice continued experience here today.
Thank you very much.
Yeah, and that concludes this invited keynote. It was really